Hello everyone, in this video we will learn problem solving that involves quadratic function. Let's have the first problem. If the perimeter of the rectangle is 100 meters, find its dimensions if its area is a maximum. Complete the table below for the possible dimensions of the rectangle and their corresponding areas. If the width is 5, the length is 45, and the area is 5 times 45, it's 225. Next, if the width is 10, the length is 40. So how come it's 40 here? Because the total perimeter is 100. So length and width should be half of it. So it should total to 50. To get the area, simply multiply, so you'll get this. So if this is 15, this will be 35, and 5 to 5 is the product. If this is 20, this will be 30, and 600 is the area. 25, so this is 25, and 625 will be the area. So if this is 30, this is 20, so it will go back to this. So 35 and 15. So if the width is 40, so it would be 10 and 400. If it's 45, 2 to 5, 5 and 2 to 5, it's 50, it's 0, and the area is 0. Question: what is the largest area? Based here in the table, the largest area is 625 meters squared. And what's the dimension of the rectangle then? That would be 25 and 25. Okay, if the perimeter is 100, make a mathematical statement of the perimeter. So you'll have this. So twice of length plus twice of width. So it's 100. So 2L plus 2W. Divide by 2. So 50 is length plus width. So that's why if we add here, it will total to 50. So length here could be expressed as 50 minus W. So what is the equation in standard form? So we will have this. Length times area. So that would be 50 minus W times W. Distribute W to the terms inside. We will get this. So we can rewrite this to vertex form or complete the square. So factor out negative. So 50 by negative, it's negative 50. Half of 50 is 25. So square it, it's 625. We add 625 here, so minus 625 at the end, but we have negative here, so plus 625. So with this, our vertex would be 25 and 625, which is exactly the same here. So the width and length is 25, and the area, which is the maximum, is 625. Okay, next. This one. From a 96-foot building, so the height here is 96 feet, an object is thrown up to the air, and it goes down. The height S of t of the ball above the building after t seconds is given with this function, 80t minus 16t squared. Again, the t here stands for time, and the S of t is the height. Question: what maximum height will the object reach? Now take note, in this one, we can identify our A, B, C. Our A here is negative 16, our B is 80, and our C is 0 because there's no constant. So let's identify the vertex using the other way of solving for H and K. So solve for H. So our B here is negative 80 over 2 times negative 16. So simplifying, this would be 80 divided by 32, or this would be 5 halves. Next, solving for K. So let's substitute. So 4 times negative 16 times 0 minus 80 squared, and 4 times negative 16. So this is 0, so that would become 80 squared, or negative 6,400 over negative 64, that would be 100. So therefore, the maximum height the object will reach, or the ball will reach, is 100 feet. And how long will it take to reach the maximum height? That would be 5 halves, or 2.5 seconds. Next, find the time at which the object is on the ground. So take note, the ball is already on the ground if its height is negative 96. Because here, the height of the ball is 96 feet. So if we'll go back to the ground, the height of the ball is already negative 96, or that would be 0. So S of t, so that would be, okay, rewrite this to standard form. So it's negative 96 here, so simplify. So transfer here, 16t squared minus 80t minus 96. So divide the entire equation by 96, we'll end up with this. Factors of 6 in order to get 5, we'll have minus 6 and plus 1. Therefore, the value for t here is 6 and negative 1. In this case, we will go for 6. So therefore, the answer for 3 is 6 seconds. So meaning the ball is already on the ground after 6 seconds. Next. Marvin has a mango plantation. If he picks the mangoes now, he will get 40 small crates and make a profit of 100 pesos per crate. For each week that he delays picking, his harvest increases by 5 crates, but the selling price decreases by 10 pesos per crate. When should Marvin harvest his mangoes for him to have maximum profit? Take note, we'll have here, these are the variables in the problem. Number of weeks waiting, the number of crates. So if he will harvest now, he will gather or harvest 40 crates. And the profit is 100 pesos per crate. So if he will harvest 40 times 100, so his profit would be 4,000. Next, if he will wait for 1 week, take note, he will be able to increase his harvest by 5 crates. So that's why from 40, it will become 45. But the selling price decreases by 10 pesos. So he will increase the harvest, but the profit will, the price per crate will decrease by 90 pesos. So therefore, his total profit would be 4,050. That's multiplying this. So after 2 weeks, so increase by 5 and decrease by 10. So it will be 4,000. After 3 weeks, increase by 5 the harvest, less by 10 pesos the selling price, then this is the profit. So the same thing until week 4, 5, 6, 7, and 8. So question. How did you determine the total profit? So take note, we multiply the number of crates times the profit per crate, or the selling price per crate. So how many weeks should Marvin wait before picking the mangoes to get the maximum profit? So in this case, the highest here is after 1 week because it's 4,050. On the second week, it decreases to 4,000 and it decreases further to the succeeding weeks. Okay, express the profit as a function of the number of weeks. So therefore, we will have this. So this would be number of crates, which is 40, times the profit, which is 100. Increase the harvest by 5, decrease the price by 10. So we can countercheck this by using quadratic functions. So we'll get this one. So using FOIL method, we will get this equation. Combine like terms, we'll get this. So rewrite this to vertex form. So factor out negative 50. So 100 by negative 50 is negative 2. So complete the square. Half of 2 is 1. Square it. That would be 1. We add 1 here. We will minus 1 at the end. But we have to multiply by negative 50 outside. So rewrite this to binomial form. This would be x minus 1 squared. Then negative of negative, that would be positive 50. So 4,050. So with this, the vertex is 1 and 4,050. So it means after 1 week of waiting, the total profit is 4,050, which is the same with our obtained table. Next, our garment store sells about 40 t-shirts per week at a price of 100 pesos each. For each 10 peso decrease in price, the sales lady found out that the 5 more t-shirts per week were sold. Question. Write a quadratic function in standard form that models the revenue from the t-shirt sales. So let's have this. let X be the number of additional t-shirts sold. So our revenue here would be price per unit or per t-shirt times the number of t-shirts sold. So that would be, take note, the price is 100 and the number of t-shirts sold is 40. And if the amount is decreased by 10 pesos, 5 more t-shirts are sold out. So take note of the equation. So using FOIL method, we'll get this. So factor out negative 50. So simplify further, we'll get this. So the vertex here, it's still 1 and 4,050. So this will be our equation. So the maximum revenue here is 4,050 pesos. And what price produces the maximum revenue? Now take note, it should not be 1, but take note, the price here is 100 minus 10x. So therefore, that would be 100 minus 10 times our 1 here. So therefore, that would be 90 pesos. The ticket to a film showing cost 20 pesos. At this price, the organizer found out that all the 300 seats are filled. The organizer estimates that if the price is increased, the number of viewers will fall by 50 for every 5 pesos increase. What functional relationship would fit the given data? So in this case, that would be the price of the ticket times the number of viewers, in which the ticket price is set at 20 pesos and the number of viewers is 300. If the ticket price is increased by 5 pesos, the number of viewers will decrease by 50. Now, simplifying this using FOIL method, we will get this one. Combining like terms, factor out negative 250, completing the squares. Half of 2 is 1 square, it will get 1. So minus 1 at the end, but multiply with the negative 250 at the beginning. Rewriting this to binomial form, we will get this one. Therefore, the vertex is 1 and 6,250 pesos. So at what price? At this price, what is the maximum revenue? So with this, that would be 6,250 pesos. Next, what ticket price results in the greatest revenue? So take note, we have 1 here. So that would be the ticket price is given as 20 plus 5x. So since our x here is 1, so let's substitute. So that would be 25 pesos. So again, the ticket price should be at 25 pesos in order to get the maximum revenue. Next, a company of cellular phones can sell 200 units per month at 2,000 pesos each. Then they found out that they can sell 50 more cell phone units every month for each 100 peso decrease in price. Question: how much is the sales amount if cell phone units are priced at 2,000 pesos? So therefore, that would be 2,000 times 200, so that would be 400,000. Next, write an equation for the revenue function. So that would be the price of the cell phone times the number of units sold. Take note, the price is set at 2,000 pesos. 200 units of phone are sold out. If the amount of the cell phone is decreased by 100 pesos, the number of cell phone units will increase by 50. Now, simplifying this equation using FOIL, we will get this one. Combining like terms, we will get this. Factor out negative 5,000. So this would be 8,000 by negative 5,000. That would be negative 16. So completing the squares, half of negative 16 is negative 8. So square that. That would be plus 64. We added 64 here. So minus 64 at the end. But multiply with negative 5,000. So negative 64 times 5,000, that would be positive 320,000 plus 400. So that would be 720,000. So at this point, the vertex would be 8 and 720,000. So how much is the maximum sale? So that would be 720,000 pesos. Next, what price per cell phone unit gives them the maximum monthly sale? So take note, we have 8 here. And the price of the unit or cell phone is set at 2,000 minus 100x. So this would be 2,000 minus 100 times 8. So that would be 2,000 minus 800. So therefore, the answer will be 1,200 pesos. Next, how much would be their sales if they sell each cell phone at 1,600? So that would be 1,600 times 200. So that would be 640,000. Next, suppose there are 20 persons in a birthday party. How many handshakes are there altogether if everyone shakes hands with each other? So how to answer this one? So we will make a table. So we have here number of persons and handshakes he can make. So if there is only one birthday person in the party, there is no handshake possible. If there are 2 persons in a party, there is only one handshake made possible. If there are 3 persons in a party, 3 handshakes are possible. If there are 4 persons, 6 handshakes are possible. If there are 5, there are 10. If there are 20, there are how many handshakes possible? So how are we going to analyze this one? So with this, what is the equation of the function? With this is number of persons present times the number of handshakes he can make divided by 2. So for example, the equation would be x, quantity x minus 1 is equal to 2. So with this, if there are 2 persons, so 2 and 2 minus 1, that would be 1. So 2 times 1 divided by 2, you will get 1. If there are 3 persons in a party, so that would be 3 times 2. Divided by 2, you will get 3. Let's check. 4 times 3, it's 12. Divided by 2, you will get 6. 5 times 4 is 20. Divided by 2, we'll get 10. So what if there are 20 persons in a party? So that would be 20 times 19 divided by 2. That would be 190 handshakes. Now, if there are 100 persons in a party, how many handshakes are possible? So in this case, so that would be 100 times 99 divided by 2. That would be 4,950 handshakes. That's how are you going to do it. So that would be all about solving problems involving quadratic functions. Thank you.